Next, the last question, 10th problem, the Tute number 1. Solve the inequality or find the set of solutions which satisfies x plus 6 over x plus 1 greater than 4. Actually now the papers, most of the recent papers are modulus inequality, but this also there in the syllabus. Sometimes for a change they can ask this inequality in the structure paper. You have to form for everything, right? Okay. So what the idea, very important, some they are cross multiple. You can't do the inequality cross multiple because you don't know sign of the x plus 1 is greater than 0 or less than 0. You can't cross multiple, right? You can't do that one. Therefore, when you can multiple cross, it become a perfect square. It become a perfect square, only chance for a cross multiplication. Okay. Therefore, see this method, x plus 6, I take the 4 this side, minus 0, then less than 0. So can I use some algebraic LCM method? X minus 4, it to be multiple with the x plus 1, no? Okay, n plus 6, okay, greater than 0. X minus 4 cross multiple, using the algebraic fraction simplification, using the LCM. So here x square, multiple the brackets, minus 4 plus 1 minus 3, okay, minus 3x plus 2 ne? Over x plus 1 greater than 0, right? Numerator further resolved into factors. Numerator can be factorized, I think. What the factors? X minus 2 and x minus 1, right? X minus 2 into x minus 1 over x plus 1, right? Greater than 0. Okay, now we will discuss about this inequality. So another chance those complete this kind of problem in the basic grade 12 lesson. If you missed that or forgot that one, see the method how to find the suitable set of solution which satisfies. So here, what are the boundaries of x? What are the boundaries? That means what the values for x depending the fraction, depending the inequality. You make every bracket to 0, then plus 2, x equal plus 2, x equal plus 1, here x equal minus 1. Okay, so if I show in a number line pattern, the three values depending the inequality, a small number minus 1, next plus 1, next plus 2, right? This is the x-axis or the set of number line along the x. So now I take, let y equal, or y or e, some say e, take e equal x minus 2, x minus 1 over x plus 1. Therefore the problem is e is greater than 0. If I use y is greater than 0. If you use e is greater than 0. So what are the value or values of x gives you e greater than 0. In such a complicated fraction, we preparing a table method or otherwise. So I follow table. You have to research this x less than minus 1 a value, between minus 1 and plus 1 values, more than 1 less than 2 value, more than 2 mean up to infinity values. So see my table, tabulate form, table form, range of x, sine, S-I-G-N, sine of x plus 1, sine of x minus 1, sine of x minus 2, finally E, yeah, sign of the E. Sign means symbol, either plus or minus, right? So if you understood one problem, you can manage any type of, but these days, these recent papers, it's not there, but school paper, Vayamba papers, Royal Vishaka, okay. Right, so less than minus 1. So less than minus 1 means up to negative infinity, right? Next, more than minus 1, less than 1. So yeah, next one, more than 1 but less than 2. At last, greater than 2. So now quickly find what are the value or values which gives you y is positive answer, right? So x less than minus 1. X less than minus 1 means you can put a number and check. Smaller than minus 1, what a number? Minus 5. Put minus 5. Minus 5 plus 1. Minus, minus 5 minus 1. Minus. Minus 5 minus 2. Minus. Less than minus 1, you put a number and check. I said minus 5. Minus 5 plus 1. Negative, negative, negative. All three collapse gives the E answer. Minus, minus, minus 3 times negative, multiple, plus, divide, minus into minus, plus, divide by minus, minus. More than minus 1, less than 1, a number between that. Put 0. Put x4 0 and check. Put the 0, positive. Put x4 0, negative. x4 0, negative. Minus, minus, plus. More than 1, less than 2. 1.5, put 1.5, positive. 1.5, positive. 1.5 minus 2, negative, answer minus. At last, greater than 2, right? X greater than 2. So, a number more than 2, positive. Plus, all together in E. So it's the method, not a modulus inequality. It's something algebraic inequality with a quadratic pattern numerator and linear form also available denominator. So the problem is, I mentioned is E. E should be positive. E should be positive. Greater than 0. Where are the positive answers? This and this, okay. These two gives you positive answers. Positive answers. Therefore, the range of x set of solution between minus 1 and plus 1 or otherwise more than 2, right? Between minus 1 and plus 1 value or more than 2 is the number line representation, right? Number line representation, number line between minus 1 and plus 1 and more than 2. Or otherwise, there are so many methods of pure mathematics notations. X is an element. X is an element 1, 2 union 2, infinity. See, this is also a pure math notation when writing answer. Lower boundary 1, upper boundary 2. 1, 2 solution between 1 and 2. Union together 2 and infinity. More than 2 means greater, infinity, right? Infinite. Or you can show like this is enough, right? This is one pattern using the unequal symbol, or using the number line pattern, or using the set notation. This is called set notation. Element, X is element of this. So it's the question, the last on that Tute booster number 1.